Chapter 1, Section 7. This is our final section of Chapter 1. Today we're going to look at rewriting equations and formulas. So let's take a look at our key concept. The key concept here to rewrite an equation for a variable means to isolate that variable by moving all other numbers and variables across the equal sign using inverse operations. So if you remember PEMDAS from earlier on in this unit, we talked about when we simplify an expression, we work from left to right through the orders of operations, PEMDAS. But when we are solving, we are working in the inverse order. All right, so we're going to undo addition, subtraction, undo multiplication, division, undo any exponents, and then undo any grouping symbols or parentheses. In our first example, it says to solve the literal equation, and a literal equation, remember, is just an equation with one or more variables, or I should say two or more variables. We have 7x minus 4y equals 12, and we're going to solve that for y. So when it says to solve for y, that means isolate y. So let's start off by subtracting 7x over to the other side of the equal sign. Now we have the equation negative 4y is equal to 12 minus 7x. The last thing we need to do in order to get y by itself is to divide both sides by negative 4. And when we divide these two terms, we have to divide both of those terms by negative 4. So in the end, we will have the equation y equals 12 divided by negative 4 minus 7x divided by negative 4. All right, now we need to simplify this and clean this up. 12 divided by negative 4 simplifies to negative 3. So y equals negative 3. And then we have a negative 7 divided by negative 4. That turns to a positive 7/4 x. So here is our new equation that is solved for y. All right, let's try example 2. It says given the literal equation 3w plus 4pw equals a, solve for the variable w. All right, now this is a little bit of a tricky one here. You'll notice that we have a w in both of these two terms on the left side. So we're going to do this operation or technique called factoring. We are going to factor out a w. It's kind of like the reverse process of the distributive property. All right, so check it out. This is what I mean. If we factor out, that means we divide it out of the two terms, 3w and 4pw, we'll be left with 3 plus 4p. And you can see that if we were to redistribute this w to both of those two terms, then we'd end up with what we started with. All right, so from here I have w times this quantity, 3 plus 4p, is equal to a. Remember, we want to get w by itself, so our next step is to divide both sides by that quantity, 3 plus 4p. All right, that leaves me with the equation w is equal to a all divided by 3 plus 4p. And that is our equation solved for w. All right, in example 3, we have the formula for the sum of the interior angles of a polygon. This is a formula from geometry with n sides. It's given by the sum of those interior angles is equal to n, the number of sides, minus 2, times 180 degrees. All right, we want to solve this formula for n. In other words, isolate n. So let's start off by moving this 180 over to the other side of the equal sign. We're going to undo that multiplication first by dividing both sides by 180. All right. Now we have the expression s over 180 is equal to n minus 2. The final step we need to do is add the 2 over to the other side, and we are left with s, the sum, over 180 plus 2 is equal to n, the number of sides of that polygon. So here's our formula, set equal to n, solve for n, and now we're going to use that formula to determine the number of sides, which remember is n, of a polygon whose interior angle sum is 1620. So that 1620 represents the value of s. So we will start off with our formula here. That's solve for n. N is equal to s divided by 180 plus 2. We're going to substitute 1620 in for s. and is equal to 1620 divided by 180 plus 2. Well, when we divide 1620 by 180, we're going to see that that's going to come out to 9, and then we have 9 plus 2, which is equal to 11. So 11 sides for this polygon, which is also known as an 11gon. All right, let's take a look at example 4. You own a rectangular lot that is 500 feet long. The lot has 100,000 square foot. Now, to pay for a new sprinkling system, you're charged $5.50 per linear foot of lot frontage. That is the width of the lot. How much are you assessed for the new system? So it always helps for us to kind of draw out what we're looking at here. And we have a rectangular shaped lot, so we'll draw ourselves a nice little rectangle here. It's 500 feet long, so there's our length here. Now the lot has an area of 100,000 square feet. All right, now we know the area of a rectangle is the base times the height, or the length times the width. And we are asked to find the width of this rectangle. What is that width? If the length is 500 and the area is 100,000 square foot. So let's plug in what we know. We know that our area is 100,000, and the width here is one of our dimensions. We're going to call that 500, and then the width is what we're trying to find. Sorry, the length is 500, and the width is what we're going to try to find. So we'll say 500 times W. All right, now in order to find out what the width of this field is, we need to divide both sides by 500. All right, when we do that, we're going to come up with a width of 200 feet. Now remember, we're charged $5.50 per linear foot, so we need to multiply that 200 feet by $5.50. When we do that, we see that our total cost for this new underground sprinkling system is $1,100. All right, now finally for our last example of this section of notes, we have the simple interest formula. Interest is calculated by taking P, the principal, multiplying it by the rate of growth times T, number of years that you grow that money for. So let's say you deposit $3,500. That's your P value into an account that earns a simple interest rate of 4.5% annually. How long must you leave the money in this account to earn $350? All right, so this 350 is going to represent our I, our interest. We know our P and our R. We need to solve for T. So I'm going to set up my equation here as 350 is equal to 3,500, that's my principal, times my interest rate. Now you got to be very careful with your interest rate. You have to change that to a percentage. So 4.5%, you need to change that to a decimal, is 0.045. You need to move that decimal 2 places to the left. And then we're going to multiply that by T, number of years. All right, so from here we're going to divide both sides by this 3,500 times 0.045 in order to get T by itself. And we'll do the same thing the other side of the equal sign. Divide that by 3,500 times 0.045. Now when you go to enter this into your calculator, make sure you have parentheses around that denominator in the multiplication. All right. In the end, you're going to come up with the T number of years that it takes for that money to grow $350.